Alright, so main focus of this chapter are what's known as molar conversions. So here's that mole, okay, you made that project, now you're going to see how you're using it. And it's basically a conversion factor. And what I taught you last week was that that mass number on the periodic table also represents 1 mole. So we can use that conversion to solve different problems. So here's the first one. Alright, so the first thing you need to do is identify the number that's been given to you. So I see 4.86 moles of CaCO3 or calcium carbonate. So what you want to do is write that down. And notice I can just put MOL instead of MOLE. It's not much, but it is an abbreviation, so you can use it. Draw the scheme. And now what is the conversion? Well, each mass number on that periodic table is comparable to 1 mole. So 1 mole goes on the bottom, and then you're going to put grams of your compound on top. All right, and I'm going to reference up here PT for the periodic table, because that's where you need to look to find the mass of these elements. And you have to take them one by one. So this should look familiar because you just learned about molar mass. So that's what you need to solve this problem. So if I look up calcium, okay, calcium is 40.10, if I round that up. Carbon, 12.01. And oxygen I like to round to 16. But how many are in your formula? I see 3 of them, so that equals 48. And then you need to add these up. So 48 plus 12.01 plus 40.10 equals 100.11. And that value is placed up here. Alright, now you should notice that 2 units will cancel, the 2 moles, here and here. And then how do you solve this? You multiply. So 4.86 times 100.11 is equal to 486.53 grams. And for now, regarding significant figures, we are just going to say 2 decimal places in your answer. So until you are more comfortable with conversions, I'm just making the statement 2 decimal places for your answers. Now you also have a pink sheet that has these conversions listed. So this one is called what? Mole to gram. You're starting in mole and you're trying to find grams. And there is a conversion on that pink sheet that will show you the basic steps of what I've just done. Alright, let's try another one. Alright, so here I told you that aluminum is used in bicycle frames. The reason they chose this, whoever builds bicycles, it has a high strength to weight ratio, so it has to hold up a person, and it's a high resistance to corrosion, which is good. You don't want it rusting on you. So, in just the handlebars, let's say there's 10 grams of aluminum. Your notes just say, how many atoms is this? We will skip this step right here. Okay, we're just going to go from grams of aluminum to atoms. So this is a gram to atom problem. Alright, you start with the number given. Draw your scheme. Alright, now I'm starting with grams. So if gram is the top value, gram needs to be the lower value here so that it can cancel. And where do you find the grams of aluminum? You find that on the periodic table. So when I look up aluminum, I'm seeing 26.98. You could have also said 27.00. And what is its conversion factor? That is always equal to 1 mole. So at this point, your grams cancel. But I'm asking you to go to atoms, not just mole. So we need to finish this. This is not atoms right now. So you have 1 mole on the bottom, and here's where that number becomes useful. 6.02 times 10 to the 23rd atoms. That is a number that is not ever going to change when you're using atoms. That is the mole number, right? What's underneath it? 1 mole. Cancel, cancel. And now, when you're plugging this into your calculator, I strongly recommend you keep this number in parentheses because sometimes the calculator doesn't read it correctly. So I will try this. Okay, my answer. Okay, I'm seeing 2.23, and make sure you read to the end of the calculator. Mine is saying e to the 23rd. You can write e to the 23rd, but it also means 2.23 times 10 to the 23rd. E stands for exponent, and don't leave it naked. You solve for atoms. So this is called a gram to atom problem. It is a 2-step problem, one of the harder ones, but you've also got this on your pink sheet. Okay? All right, let's try another one. All right, this is actually going to be a very similar problem. We have silicon, which is used to make computers. So I'm starting with what? 5.68 grams of it, and what am I trying to find? Atoms. So this is another gram to atom problem. Start with the number that was given and draw your scheme. Gram is on top, so gram will go on the bottom. The element in question is silicon. Where do you find the grams of silicon? I believe that's on the periodic table, so make sure you're looking at that top decimal number. I'm going to say 28.09. You could have said 28.10 as well, that's fine. And what's the conversion? It's 1 mole, that doesn't change. So right now, gram and gram cancels. But you are not finished. I asked you for atoms. So in 1 mole, why did I put it on the bottom? So that it cancels. And here it is. 6.02 times 10 to the 23rd atoms, and then you need to solve. Make sure you are multiplying as you go across, and then dividing, and keep that mole number in parentheses. All right, my answer is 1.22 times 10 to the 23rd atoms. All right. Last problem here. Chromium. Okay, it's another metal that is added to steel to help resist corrosion. Get it like stainless steel. Okay, it doesn't stain. So what do we have here? In this example, I have atoms, and I'm trying to find mole. So it doesn't matter if you're starting with this large, like, scientific notation problem. So what? Atoms is supposed to be bigger because they're very tiny, and there's a lot of them. So write it down. Draw your scheme. And now in this instance, if atom is on the top, atom will be on the bottom, and there's that same number next to atoms. And what is that comparable to? It's your project, 1 mole. And you're actually finished. Cancel, cancel. Now please be careful when you plug this into your calculator. I strongly recommend parentheses. If you are getting any exponent to the 46 or 50 something, you did something wrong when you plugged it into the calculator. So let's try this. Okay, I got 8.31 times 10 to the negative 4, and my unit is mole. So these are called molar conversions.